overdose death. The individuals here, we are told, are individuals 15 and over in the United States at two different points in time, 2019 in blue, 2020 in green. Well, we are told that this represents in the graph overdose death rates by selected age group. So that means that we have a death rate for each of several different age groups. And we have that on 2 different years. So that means that beyond the fact that we have 2 years, we have one variable, which is what is the age group of the individual, and another variable, which is, well, did that individual die of an overdose death, yes or no? And therefore, it's a categorical variable. What is shown on the vertical axis is a summary of that variable. It's what fraction of all individuals in any age group in one of those 2 years did die of a drug overdose death. Everybody else did not die of a drug overdose death. So the death rate on the vertical axis, it says death per 100,000 population. Why per 100,000 and not percent? Well, because thankfully, those events are relatively rare. So for example, here, the first leftmost column, we have an 11.2. Well, we can see that it represents the 15 to 24 age group for the year 2019. So what does that tell us? That tells us that we're looking at individuals in the US who were ages 15 to 24 in 2019. And what the height of that bar and the numerical value tells us is that in this group, the death rate from drug overdose was 11.2 per 100,000. That means that for every 100,000 person ages 15 to 24 in 2019, 11.2, so roughly 11, died of drug overdose. And that means everybody else in that group did not die of a drug overdose. The next sets of columns do the same thing, but considering a different group. So what can we say about drug overdose death rates in the US on those 2 years? Well, we can see that thankfully they are, relatively speaking, somewhat small. That's why we measure them in per 100,000. We also see that some age groups have a higher death rate than others. That's why the bars are taller or shorter. So how does that inform our interpretation in context given the proposed conclusions? So which one is correct or incorrect and why? The first proposition is, in every age group shown, the rate of drug overdose death increased from 2019 to 2020. Yes. The size of the green bars is taller than the size of the blue bar in each of those age groups. So yes, we have another proposition. In both 2019 and 2020, distribution of drug death was roughly symmetric. This is absolutely incorrect because we're not talking about a quantitative variable. Skew, symmetry, outliers are terms, statistical terms that refer to the shape of a quantitative distribution. We do not have a quantitative distribution here. What we have is a categorical variable. This is death, yes or no. And the summary for that is a death rate, right? A proportion of death from drug overdose in each of those different age groups. And because those are different age groups, you could sort them in any way you want. You could go like here from youngest to oldest. You could also start with oldest to youngest. You could sort the columns by which group has the highest death rate. So you could start with the 35 to 44, for example. The placement of those 12 columns is entirely up to whoever wants to create this graph. And this is why we cannot talk about some kind of symmetry or skew. It does not make sense when you can reshuffle the columns whichever way you want. Third proposition. In both 2019 and 2020, the rate of drug overdose death was highest for people aged 35 to 44. Let's look, for example, at the data for 2020, so the green columns. And what we have is 6 different death rates. And we can see that the age group with the highest column, so the largest death rate, is the 35 to 44 age group. And when we look at the 2019 data, this is the same thing. So yes, this statement is correct and substantiated by the values. Last proposition. In 2020, The majority of drug overdose deaths among Americans aged 15 and over were people aged 35 to 44. So this is something to be very careful about, and it's a common mistake in reasoning. What the graph does show is that of the 6 age groups we have, the 35 to 44 age group had the highest death rate. It just happens to be 53.9 per 100,000. But it doesn't tell us, out of all the people who died of drug overdose, what percent were ages 35 to 44. We have no idea. This graph does not tell us that information. And we cannot even try to compute it because we don't know how many people total of the American population are in each of those age groups. The question is asking about the inverse conditional distribution, and it cannot be inferred from the information we have here.